Now we have a problem that has all the properties of gas shown in a PV diagram. So, with the given PV diagram of 3 moles of a monoatomic gas, find the temperature at all points, the work done from B to C, the work done from the whole process, and the types of processes from point B to point C and point C to point A. The first part is finding the temperature at point A, point B, and point C. Now to find the temperature, we just use the PV-nRT equation and substitute the numbers and use basic algebra. First, we have to find the temperature at each point. First, we substitute the numbers into the PV-nRT equation. The pressure, volume, and moles are given in the problem in the diagram, and R is always the constant 8.31. At point A, pressure is 800 pascals, volume is 1 liter, N is 3 moles, R is always 8.31. Now that we have the numbers, we set up the problem to solve for T by dividing by 3 times 8.31. Then it's a simple matter of calculator work, and the answer is 32.1 Kelvin. For point B, it is just the same as point A with different numbers. Pressure is 100 pascals, volume is 12 liters, moles are 3, and R is 8.31. Set up the equation to solve for T again, and let the calculator work. And the temperature is 48.1 Kelvin. Lastly is point C. Once again, it is the same as the first two. The pressure is 100 pascals, the volume is 1 liter, mole is 3, and R is 8.31. Set up the equation for temperature again, and the answer is 4 Kelvin. Now we need to find the work on the gas from point B to point C. We need to use the work equals P delta V equation since the process is isobaric. The pressure is 100, and to find the change in volume, simply subtract the final and the initial. Now multiply the pressure and change in volume. The work on the gas will be 1,100 joules. Next, we find the work done by the entire process. Since this is a cyclic process, it is simply the area enclosed by the process. The equation to find the area of a triangle is 1/2 base times height. The length of the base is 11 and the length of the height is 700, and they are over 2. After the math is done, the work is 3,850 joules. Last thing to do is to identify the types of processes from point B to point C and point C to point A. The process at point B to C is isobaric because they have a constant pressure at 100 and the line at the PV diagram is horizontal. And from point C to point A is isochoric because they have a constant volume and the line in the PV diagram is